Alright, so in the last video we talked about how to find the measure of an angle using a protractor, and we talked about acute, obtuse, right, and straight angles. In this video we're going to talk about angle addition postulate. And basically what this means is the very wordy jargon geometry definition of it. If point B lies inside angle ADC, so draw an angle here. It's not going to be the prettiest angle, but it'll do. Alright, put some points. So here we have angle ADC, and this is point B. So basically if we have two adjacent angles, because that's what we have, ADB next to BDC. So if point B lies inside angle ADC, then angle ADB, so that's this angle right here, ADB, plus angle BDC, so angle BDC, that's this other angle, will equal angle ADC. So basically, one angle plus the other angle equals the bigger angle. That's as simple as what the angle addition postulate is. Or if I know the big angle and one of the inside angles, then I could find the other inside angle using subtraction, because that's the opposite of addition. But that's the angle addition postulate, so let's use it. So here a figure is shown with some angle measures given. And it doesn't just have to be two angles, it can be multiple angles as long as they're adjacent and they make one big angle. Alright, so some angle measures are given. The measure of angle PTS, so that's the big angle here. So this angle right here is 96 degrees. And I like to label my pictures, so my suggestion is, if it helps, draw yourself a sketch, which means it doesn't have to be accurate, but a sketch of the angle on your work paper, and you can write all over the angles as needed. We're wanting to find the measure of angle QTR, so we want to know this measure right here. So what I do know is that the three angles add to equal the big angle. So I know that 28 plus 49 plus, we're going to call this x because that's what we don't know, so plus x equals our big angle of PTS, so that's the 96 degrees. So equals 96. That's my equation. From here, I'm going to combine like terms, so that'd be 28 plus 49, which is 77. So I have 77 plus x equals 96. Now, to get x by itself, I've got to move the 77 to the other side, so it is positive, so I'm going to subtract 77 from both sides. And so then x will equal 19, which means, because we want to know the measure of angle. Oh, here I go erasing a whole bunch of stuff. That was not on purpose. The measure of angle QTR will equal 19 degrees because x was angle QTR. Things to keep in mind. We do not have negative angles. So if we're talking about an angle itself is going to be positive. But if we're looking for x values could possibly be negative. But in this case, because our x was Excuse me. Because our x was the angle itself, I would know something is wrong if I ended up with a negative answer, and I would need to go double check either my equation or my math in getting the answer. All right, moving on to the next example or slide. That's what I'm really looking for. We've got some more key terms. So two angles that measures add to 90 degrees. These are complementary angles. I had a para one year help students remember this by saying complements are always right. So we know that a 90-degree angle is a right angle. And we always enjoy a complement, and there's nothing wrong. You know, it is always correct or right to compliment someone. So complements are always right. These angles can be adjacent, but they don't have to be. It's any two angles that add to 90 degrees. The thing is that it is two angles. Just like two angles that measures add to 180, those are supplementary angles. Supplementary. I don't have any cool way to remember that, but if you remember complementary is 90 degrees, then supplementary has to be 180. All right, so our next example, angle 1 and angle 2 are complementary angles. So anytime I would see this, I would put the fact that I'm going to 90 degrees just to help myself. The measure of angle 1 is 58, so on my diagram, I'm going to put a 58 degrees. And the measure of angle 2 is 4x. Find the value of x. So since I know that these are complementary angles, I know that they add to 90 degrees. So I know that 4x plus 58 will equal 90 degrees. The other thing is, since these are adjacent angles, I can use the angle addition postulate to say that angle 1 plus angle 2 equals 90 degrees. Notice that in this, they give us the little red box. Excuse me. The little red box to indicate that it's a right angle. Okay, so from here, this is a two-step equation. So in order to solve a two-step equation, we're going to start by subtracting 58 to both sides. So subtract 58, subtract 58. So then the 4x comes down, 4x equals, and 90 minus 58 is 32. And then we're going to divide both sides by 4. And so then x will equal 8. And that's what it asks. Find the value of x. And so then that is my answer. The value of x is 8. Ta-da! So that was complement. Example 3, find the value of x using the measures of the two given adjacent supplementary angles. So we know that they're supplementary, so that means 180 degrees. And I know supplementary angles add, so I'm going to take 2x plus 84, and that is going to be equal to 180 degrees. From here, again, just a two-step equation, so I'm going to subtract both sides by 84. So then 2x will equal 96. Divide both sides by 2 because that's the opposite of multiplying, and x will equal 48. And again, it's just asking for the value of x. Find the value of x. So x equals 48. And we are done. It may, in your problems, may just say, what is the complement of 12 degrees, or what is the supplement of, and give you an angle. And really, you just need to know that you take 9, if it says complement, take 90 and subtract the angle. If it says supplement, take 180 and subtract the angle they give you to get the angle that you're missing. And that is it. So until next time.